Hi, today we're going to discuss about this paper, probing via prompting. So this paper gives a new way of probing, which uses prompting. Okay, so what does probing means? Probing is about understanding the linguistic properties of a model uh, using some auxiliary model. So, for example, there is some text. It's given to a pre-trained model, and you get some representation, and that representation is an input to auxiliary model that's give you some label, the prediction. Okay, so there are two components. One is some language model and there's auxiliary model. What is prompting? Prompting is there is some input, right, and there is some prompt which is attached to a prepend to this input. Now it can be hard prompts or soft prompts. Soft prompts are continuous in nature, and or it can be kind of hard prompts which are templates. So they are using this kind of method to do the probing. Okay. So this paper introduces a novel model-free approach of probing by formulating the probing as a prompting task. So they have 5 probing tasks, and yeah, that's the main idea of this paper. So so this is thus, and they compare this method to the baseline, which is diagnostic probing. So what they have is, this is the input text, this is a pre-trained model, and then they give it to a probe, which is some auxiliary model. It can be logistic regression or multi-layer perceptron. They're using these two, and then you get the prediction. So this is their baseline, and then they're comparing that with their own method. So here I have a day off, and so what they're doing here is we reformulate named entity labeling into an language modeling task by concatenating the given span a day. So they have some sentence here, this whole thing, and then this span of the sentence. So they have these new tokens, separator and end of sentence. So they also increase the vocabulary, and they have these new tokens. So they have all this as input to the model, pre-trained model. This is kept frozen, and then they have some prefix. These are soft prompts, and they are trained. So here this was getting trained. The parameters of the model, auxiliary model, was getting trained. Here the prefix are gonna get trained, and they have this language modeling task. They have language modeling task, and it's gonna give you the prediction. So this is their overall method. They are using GPT-2 small and for experiments. So they are using these 5 data sets, and you can look into the details of how the template looks like. So they have the pattern. So pattern is like X is some sentence. They have a separator. They have S1 and S2. This is like they have some kind of template. You can see the templates here also. Okay. And they have a verbalizer where the labels are mapped to the verbalizers, and these verbalizers so these are also new tokens. So each class has a new token. So the vocabulary has been increased with these tokens. Okay. And the newly added rows in the vocabulary, their embeddings are randomly initialized from a normal distribution with the mean of 0 and variance this much. Okay, and they're not updated during training. Sorry. So prefix tuning is so in the prefix tunings they prepend the pattern with a prefix, and that we discussed before, and they are using continuous prompt. Okay. So the tasks, there are 5 tasks. Part of speech tagging, constituent labeling, named entity labeling, semantic role labeling, and co-reference. Okay. And their baseline is, so what we have right now is the method, the data set, the model, and the baselines. These are the baselines where the auxiliary model, this probe is either logistic regression or multi-layer perceptron. Okay. Now there are three methods, two of these and one of this, and then there is a comparison. Yeah. Um, okay, so this is the um, result. These are for different data sets, and this is different methods. Majority is majority class prediction. Chance is just a random guess, and then pre-trained and random. So pre-trained is the pre-trained model plus some auxiliary model like ML and multi-layer perceptron or logistic regression. Random is the model itself is not trained. It's the parameters are randomly initialized. So there are two blocks here. One is the model and one is the probe, right? So if it is so what we want here is that the probe shouldn't learn the linguistic properties. So it is possible only when we have it should predict the model's property and not learn the task itself. So when we do it as random, so the results is gonna drop. It dropped a lot, saying that this new probing method is a better one than the before. I can show you. So result is, we observe that when GPT-2 parameters are randomly reset, PP performs substantially worse than the other two diagnostic probes, and which we can see that. So this result suggests that PP learns much less about the task on its own than the diagnostic probing, which makes it a better probe in terms of selectivity. Okay, but then there is a contradiction in the next test. So what they're so the other test they are using is control task. So the key idea of that control task is that it can only be learned by the probe itself. So a selectivity probe should have high linguistic task accuracy but low control task accuracy. So if I run the models, the setup models on these tasks, we should get a small accuracy. So that means the probe is better. Okay, but if you see here, so they have a controlled version of this task, POS task, and you can see here that PP has the higher accuracy than these two, which is a contradiction because now this says like PP is not a good probing method, so it's a contradiction, right? Therefore, if we were to use so it's a contradictory thing there. So to resolve the contradiction, we re-examine the implicit assumption behind control task. So they talk about what was the assumption here, and then finally it is clear that accuracy on the control task under all three methods drops substantially when switching to the random model, which means the accuracy of the control task depends not only on the expressivity of the probe but essentially also on the representations. Okay. So PP still involves okay, so that's the other thing. Now they also discuss so so they have another some place. Yeah, so they also run the same thing for the control task with the random model, and then they see that this has the least accuracy, and having the least accuracy on a control task means that this is a better probing method. And the other experiment they did was on center of gravity. What it means is a higher center of gravity means the information for the task is encoded in higher layers. So there are different layers for the model. So what's interesting to see here is if we change sorry if we change the probing method, the center of gravity changes. So we have to be very careful in picking up the probing method. Yeah, so that's about this paper, and for more details you can go through this paper. Thank you.